Okay. Thank you, Dr. Idrabani, for the reply. We'll go to the next speaker. I would introduce next speaker is Mr. A.P. Ramachandran. He was my classmate also in bachelor's, and he has actually, after finishing, he is the first guy to start in computer software business in 1983, and he's one of the major ITS BPO player in Coimbatore. So he was in IT industry. Before that, he was also he made a syllabus for the +2 also. So his question is, then he has been into IT Park, the first IT Park in Coimbatore he started, and first tie-up with IBM mainframe, everything. But basically, he's also a farmer. He's also agriculture engineer, and he is now into venture of really modernizing the agriculture. When he will talk, I will talk about agriculture part. Let him talk what he has done, what his problems, what are the challenges, and what he recommends to all the youngsters to come. A.P. Ramachandran, please.
Yeah, thanks, Syed. Thanks for introducing. Hope my voice is clear.
Very clear. Please go ahead.
Okay. See, basically, to all the panelists and the participants, I'm a little different guy. I'm not an academician or I'm not a researcher. I'm basically a businessman. Okay. And how I just want to explain how a businessman looks at automation in any field, whatever it is. Today it's agriculture. So any field, how the person is going to look. So when we were been from 1983-84, we have been in IT software and ITS, BPO and all that. So when 2013-14, our family decided to diversify into agriculture. The first point we thought how a daily operation can be automated. And when we look for a technology availability and the process availability and the market, we find it very, very difficult. It was just not available as what we want. And one or two MNC companies were available, but the pricing part was very, very exorbitant. It's almost 30-40 lakhs for a thing with the AMC and other things, where a normal farmer cannot afford to go for such a facilities. So the first thing, I'll just combine how we have graduated, how we have grown and stage by stage. The first stage, when we said, many people suggested, are you interested in organic or are you interested in inorganic, and your soil is getting bad, and how you are going to do, and how whether you are going to use a chemicals and non-chemicals. So many things came in. So when we said, okay, how we are going to do, the one first point we come to understand that in most of the agriculture, whether it is a flooded irrigation, the fertigation is done on a broadcasting, and it is done on a weekly basis or once in fortnight. And even on a drip irrigation, the fertigation is done on a weekly basis. So one thought came in, we have related a human being unto a plant. And for example, a human being, this is what we work. A human being required 800 kilocalories a day and 2 to 3 liters of water a day. So if I bring in 20-25 liters a can of a water and 8,000 kilocalories of excellent food, and make you to eat within 2-3 hours and consume everything, whatever it is available on the table, and next 10 days, nothing is available. So this is what it was, and almost 99-100% of the people, whatever the way, whether it is a broadcast, whether it's a flood irrigation or whether it is a drip irrigation, this is what happening. So the chemical applications, your fertilizers, all that, the unutilized portions were going into the soil, and the soil becomes bad. So we thought the fertilizer and the water has to be given on the right time, the right quantity, and the right place. Then how to do that? So that is where we started our automation. So when we say the fertigation, so we have just taken the inorganic, organic on the side, because that's a chemical, non-chemical, and how to do that. So when we started analyzing, okay, I'm here to give a water or a fertilizer or whatever it is for the plant at the right time, at the right place, and the right quantity. We have used a lot of automations and embedded softwares and to feed the water and the fertilizers. So when we did that, we analyzed what are the fertilizers available, whether it is a chemical fertilizers, where it is like I can even treat on a medical talk. You are given a syrup or a tablets. You just eat. It goes into your digestion system. After the digestion, it gets into your blood and you get purified. And the other one is the intravenous, direct to the blood. So we started using the amino acid based fertilizers, where it is a soluble and it is directly goes into the as an input to that. For example, if I take a urea, it goes into the soil, gets converted into the plant capabilities or absorption, then it goes into the plant system. Whereas if you use the amino acids, so it becomes automatically a non-chemical concept. So this is the first level of methods we used, and we have used a lot of things how to think, and we have 7 pumps. Vijay, can you just show me the small pumps, the last but one?
No, next, you have to tell us next slide only will come.
No, this is don't have
no, it will go one by one only. You tell me which slide.
Only the last point. I just wanted to show what are the facilities we are using. No. The one last but one, the pumps what we are using for the fertigation pumps. The small 7 pumps, yeah.
Go ahead again.
Go ahead. Yeah, this is what.
Stop there.
So these are the previous
go back.
one. Yeah, go back. So these are the these are the pumps we use, and where we pump in 5 ml to 500 ml per hour, because the logic is we use 50 ppm to 150 to 175 ppm fertigation to all mixed, like your nitrogen, phosphate, and potash, and micronutrient, and all that mixed together. We use around 50 ppm to 150 to 175 ppm. So each pump has to pump in 5 ml to 50 ml per hour to mix into the water. Then the major thing came in when we started pumping on from these small pumps. When a water is pumped from the well or a tank, it comes on a 5 kg to 6 kg pressure, and with a delivery rate of almost 40 to 50,000 liters per hour. And when the small quantity goes into that, it didn't mix to that. So many people suggested, okay, you need another 5 HP or a 10 HP motor, where it is you mix all this thing and pump into that. So it adds to the system like a Venturi system, because normally we use the Venturi system, but here the Venturi is one single delivery. Here I'm delivering almost 6-7 things, because we are using Panchagavya, we are using amino acids in different forms. So all that 7 items we are adding into that. So we find it difficult. So then one of my friend, liquid flow meters, he said, okay, you are pumping in a pipe of 4-inch or a 5-inch pipe. So increase your pipe size to 8-inch for a 2 to 3 feet, so that a pressure drop will happen. So when you add with a pressure drop to these items, it get automatically things. Because I say one major point in agriculture, power availability. You don't have a power, it's a zero power. You, whatever the automation systems you plan, you think for how to reduce my power. Without power, how my automations will work. So that's a major item we have to keep in mind whenever you are doing for agriculture. So because of power, and the major thing is it's an agriculture feeder. Agriculture feeder, the power stability is very, you can't have a stable power. You get about 280 volt to 400 volt. So, and again, three phase, you very rarely get three phase. Always, most of the times you get a two phase lines. So these are the constraints when you use on the lab and the testing point and to the field level. So we have overcome all these things. We took a long time. We have overcome all these things. And now for us, the embedded system, now we are converting into a PLC. The embedded system is fine and we are able to do all that. So when it happens, we thought, okay, the soil has got some pH, my water and adding to this fertilizer has got some pH. So when both mixes, can we make it a neutralized? At least 6.5 to 7.5, nearest to the neutral. So we took sensors, get back the results, pH results, and using pH results, after mixing all that fertilizers and other things, it recognizes what is that when it goes into the soil, mixes with the soil, what is that pH you get. So it depends on that, we add alkaline and acid so that when it goes into the soil and mixes with the soil, it is almost nearest to the pH. So this is the exercise we have done. And on this exercise, we have found a lot of interesting stories. Like when we are using sensors, we are not able to take cables and the wires for a long distance. So we used Wi-Fi systems, and Wi-Fi systems, first 2-3 months, it went very well. And all of a sudden, it on a day, it went bad, or its signals were dropping. We are just not able to identify what are the problems it gave. Then we identified, because that was a sugarcane field. When the sugarcane grows very well, the plantation densities becomes very big, the signals got blocked, and we are able to get only 30% level signals where the system doesn't work properly. So now we have changed that also, because the pH of soil doesn't change every day. So what we thought, okay, every month we'll take a sample, we analyze the pH, and that pH we have transferred to a database. So when that particular wall, that particular field, when it goes, that takes the pH from the database, and the pH, all the mixers take, and it adds alkaline or acid. So these are the tremendous, what you call, redo, get, and why it is not working, all that. So this is what we have been, the first level of automation we have achieved. Okay, I'm applying my water and the fertigation where it doesn't mix with the soil or the excess, there is no question of excess fertigation which goes into the soil, or the fertigation goes into the soil and the soil gets converts the fertilizer for the intake of the plant. So what we said, okay, we now have amino acids where it is like intravenous, it directly goes into that, and it is soluble with the water, and when it's actually goes, and whatever the water goes into the plant, the plantation also, the fertigation also goes into that. So that is the first level of automation we have reached. Then the second level is the pest and disease management. So that is where your chemicals and all that comes in. So how to avoid pest and disease management? Disease management comparatively is simple, because you have if you select your seedling a proper way, and you make the base soil in a comfortable way without nematodes and other things. And the stamina, because it is on a daily basis, like what we take breakfast and lunch and dinner, it is done on a 3 dosages. The water and the fertigation is done on a 3 dosages, like a breakfast, lunch and dinner. So automatically the stamina of the plant improves. When the stamina of the plant improves, the diseases doesn't come, or the plants has resistance to withhold or come out with the diseases. Then the major thing came in the pest management. So the pest management, we have what you call through agriculture process, we have controlled a lot. That is agriculture process like a repellent and different crops, where if I grow banana, I grow some flowers. Okay, so it repellent the what you call pest, or we can see the pest attacks or things, so that it is easy for us to control. And so how to avoid the chemical spraying, because the major in agriculture today, what we are talking about, organic, inorganic, is mainly 3 things: the pesticide, insecticide and the weedicide. So the fertilizer, even it gets converted or soil gets bad and your final product doesn't get affected. But the final product is a chemical is only on the pest and disease management spraying and the weedicide spraying. So how to avoid? In an open system, we find it very, very difficult for the pest management, though we have traps, light traps and all that. So we thought, okay, to overcome all that, and again, natural, because sometimes the rain comes on an off season, the wind is in a different season. So can we avoid all that to overcome the natural phenomena and natural things, how to handle that? So we decided finally, okay, can we go for a controlled environment? This is how we have just moved from an open cultivation, automation for a fertigation and the irrigation, controlling the whole thing, and pest management and the disease management. Then we thought, okay, can we go for a what you call controlled environment, where the polyhouse, greenhouse and net house, all different types are available. So we have selected polyhouse for almost 8 to 9 acres. It's a very huge thing for any people. Many people have said you are going too much, but we said, okay, we want to do agriculture and industry, because from the software side, we know what is industry 4 and we have expertise on the industry 4. Can we at least do something the industry, at least not 100% industry 4, can we do something to reach to that level for the agriculture as an industry? That's a mindset we thought we'll go for that. So when we decided for a polyhouse, the major issues are control, temperature control and humidity control, because the outside is nature. You don't have any temperature control. If sun shines, it's a more on heat. If it is a rain, it is a more on rain. If it is a wind, it's more. But in polyhouse, you can control everything. You can control the sunshine. You can control the wind is totally zero, and you can control the pest and the disease going. But one thing is, if by bad luck, even a small pest or a small components goes into the polyhouse, because it's a controlled environment, as the crop is grow very well, the pest also grow very well. So you have to be very, very careful in entry points and all that into the polyhouse, so that there is no pest or any of the parts goes into the polyhouse. So when we decided, the one thing is temperature and the RH control. How to do the RH control? The normal polyhouse, the industry polyhouse, everybody puts a foggers. The foggers, because we just went for the foggers on the first time. And the foggers, we found the major thing, the pressures from the water line. Because the agricultural feeder, we don't get a standard voltage. It varies from 280 to 400. So sometimes we get a very good pressure, the fogging will happen. Sometimes the fogging will not happen. In that time, water drops will happen. When the water drops happens, it's a havoc. Because when the flowering stage, when the water drops happens, the entire flower aborts. So you have an abortion of entire flowering. So the whole yield is zero. And all the type of diseases will come because the water stays on the leaves and other things. You have all the virus diseases and all that comes. So we had a very, very tough time how to overcome all these things because it's a very, very difficult, or you need a generator where you can't have a cost consideration. Then we decided, okay, can we go for a humidifier? Though it is a little costly and a little power driven, we thought, okay, it's a good to have a humidifier, and we went for a humidifier, and that saves the whole issues. And we don't have a foggers now, we have a total humidifiers, and that spreads the temperature where we have tremendous control on a humidification and the temperature. So it's all the sensors are there, so it's automatic. So
one clarification. Sorry to interrupt. One clarification. Actually, I want to remind you that Ramachandran is sitting at home. He doesn't have the problem with laptops and all, so he cannot show the control systems and other humidity controls. So those who ask me about this, I think he will continue F9 only now. And I will request him to show the rest of the slides, control a little bit, idea what other slides at the end of it. Please, Ramachandran, continue, please.
Yeah. So we have used a humidifier, and humidifier with the industrial fans. So get the cool air throw into the, because each polyhouse is 1 acre, 4,000 square meter. So it's a size of 100 by 40 meters. So 100 by 40 meters, locating a humidifier itself was a big exercise. Where to locate, how to spread the cool air. I can't have a 15, 16 humidifier to get the thing because my cost, the power availability, then how to minimize my power requirement. All that, it's a major thing. Keeping that, we have a thing, and what we have used a very minimum 3 to 4 humidifier, and with 5 to 6 HP power, and used industrial fans to push the air into the corners and all the surroundings. So when that happens, when the humidifier and other things, the crop, and with the right time and the right quantity of the fertigation and the things, the crop yield and the crop things were okay. But still we find the best moment, because when a person moves from one field to the other field, the workers moves and the staff moves, the supervisors moves from one field to other field. A small particle virus like white fly and other things, where you just can't even identify how it goes. Only when it grows, you can identify into the field. So how to grow? And as we are doing this, one of my friend in Coimbatore is manufacturing ozone generators. So he said one of the system he delivered to Netherlands for a fruit cultivation, and they add the ozone into the water for the irrigation. So we thought, okay, can we try that? And we tried that, keeping the ozone generator put into the venturi, into the water line. And it gave us excellent results. Nematodes were totally, it becomes zero. We didn't have any nematode issues, it becomes zero. But the whole problem is like a line of control. If you excess ozone, it affects the root zone. If it is a low, your nematodes is not fully controlled. So it becomes a little, and again, the adding point of your ozone air to the delivery point, it should be less than 50-60 meters. If it is more than 50-60 meters, the ozone effect goes out. So then we said, okay, can we use this into the air, in the polyols? So from the humidifier and the industrial fan, on the flow points, we just added, we have just put the pipes of gas pipes of the ozone generator, where the ozone is just spread onto the entire field, or 1,000 shed. The entire shed, it's a spread. So you'll be tremendous effort. Almost my pest control is zero. We are not spending any chemical or any spray or anything for a pest, because it's now totally controlled from the ozone. So whenever the humidifier runs, the ozone runs, and it's a sensor control, it automatically runs. The ozone goes into that, and with the ozone, it kills it, because it's an extra oxygen, O3, and the O3 adds into the things, the minor things goes into that, and it just gets killed. So this is the levels we have done. And there were many challenges we found. Though we are a businessman, we couldn't find, because it's a research, though as a business, and when any business we do, we know what we are going to do and what's the time frame, whether it's a 3 months or a 6 months or a maximum 1 year, we finish our either a factory or a start running up and run. But here it's a total R&D research. Every day is a research. Even today we are doing a research. It's not a full-fledged. I cannot say it is 100% it's thorough. Every day we are on a research. Something comes, something, because there was no data available in the industry.
Ramachandran, another 2 minutes, please.
Okay, I'll finish it. Yes. So there was funding was a big issue, because though we have a lot of contacts from VC funding and other things, for agriculture, India is not allowed foreign FDIs and other things or VC funding, because the agriculture is, and we cannot show this as a separate company or a development and other things. So, and that's a major thing. And the next point, we are today, any polyhouse or a greenhouse you go, there are only few crops available, like your cucumber, capsicum, and tomato, because it's a non-pollination products. It's a monopollination. It's all the flowers are female flowers. But when we want to grow all types of vegetables, and we have used the wind inside the fans which generates, and the humidifier which generates, so that we have used as a for the pollination, and we have successfully done crops like vegetable crops like bitter gourds and brinjal, bendi, and all that. Now we are moving towards non-vegetable crops like a sugarcane, turmeric, and muringai leaves and curry leaves. Where for sugarcane, we are already discussing with Sugarcane Breeding Institute and Banariaman Sugars, where it's a local sugar mill, and for the Sugarcane Institute for the technical support for the sugar growth and sugarcane growth, and as a using the thing. And just for information, when we as the discussion progressed, the director of Sugar Institute told, as of today, there was no sugarcane growth in the polyhouse. So it will be a number one in the whole of a thing. So we are working just because of the COVID-19, these issues, it just stopped. Maybe once it's over, we'll be signing a official thing with the Sugarcane Breeding Institute and the Banariaman Sugars. We're bringing, and similarly, we are trying for turmeric and banana and muringai leaf and curry leaf and all that, because the vegetable market is fluctuating market. And here we need to get a minimum things. And the next level, we thought, okay, why using one level of a soil? Can we use a multi-level? So like your flats, can we have 5 floors, 8 floors, 7 floors like that? So already my experiments were started. There we have a soil-based multi-levels and non-soil based multi-levels. Non-soil based multi-levels, there are few people, my own friends and others are working here like aeroponics and other things. I'm just waiting for their success, 100% success, whether it's we can use that, adopt the technology as it is. But soil-based multi-levels, we don't have a much people for a variety of crops. So we are trying to go that. That means in 1 acre, can I take 10 acres, 15 acres multiplication? Because the one advantage in a polyhouse, in normal, for example, turmeric in a normal thing, you go for a 10,000 seeds, whereas in a polyhouse, we go for a 40,000 seeds. So it's even a seedling, we increase, the spacing is reduced, even the things is reduced. So you have multiple growth, multiple yield, and whereby reducing the cost and other things. So maybe by 2021, we are expecting agriculture 4, industry like industry 4. I'm just visualizing, can we bring in agriculture 4 as a total automation and do that. So I have a few slides which are my photos of my polyhouses, which I can just one by one, you can just move.
Setu, go to from top and come down one by one, please.
Yeah, one by one. It's all.
Yeah, top you go first. First slide.
It's all. Yes. All polyhouse, and in the polyhouse normally it's about 8 to 10 feet, but we go for a 14 feet, so that a multi-level we can do for a multi-level. This is all, of course, capsicum, cucumber, and all that. It's initial days. And these are the ICs and
stop the slide.
All that we have used for systems and how we have built. We have just built many numbers finally to reach, because absolutely there's no data available. It's all trial and error. We achieved all these things, and finally today, yes, we have some knowledge. I can't say it's we have any very knowledge, but we have some knowledge, and we can definitely support anybody. And any
Ramachandran, time is up. We have to close in another few minutes.
Yeah, sure. Thanks, Syed. Thanks for all the people. Any information or anything needed, I'm available on my email and the phone.
Thank you. Thank you. It's a very interesting topic from a businessman and who is want to make an agriculture as a business. And we heard his problem. One, he told about the Wi-Fi didn't work. That's very simple. It has to put in the height. So the question is what the training is about, to learn different technologies in communication. It's very important. Second one, what you're talking about, the precision agriculture, we don't have enough suppliers. When I talk to universities or professors, they say, we have done that, we have done that. When I go to field, I can't find. And at least he is doing, I have seen, and I think here I have, in this panelist, 2 people have visited his farm and seen it working. That's before 1 year. So I would now ask short questions. I will leave it to Indramani now. Any questions, how we go about it? And there are questions, or a lot of people have asked me about drones. They want to have a lot of questions they have. I think Dr. Indramani, you have to guide how to go, because time is short now.
Yes, I request the participants that please just share your questions. We will share the email ID of Manjul, and that are even we can write to him and get the answer, because we would like to even compile those questions and answers.
Before,
So this is
Hello.
one thing. Dr. Jha wants
yeah,
to say.
Yeah, Dr. Jha, please. Jha,
yeah,
please go
doctor,
ahead.
I have some observations.
Yes.
Actually, in the first
Yeah.
presentation where Dr. Manjul and his team was excellent, very good. And he has presented about the drones applications. But here what we feel that we are lacking in the capacity buildings. As you have told that our syllabus and other things are not updated up to so much. So can Manjul and his team or any other person can give some trainings to some our scientists or some budding students, PhD students for design and fabrications of drones itself? Because
Yes.
here you have bought the drone and the equipped with the equipment and sensor and all the camera, then analysis part is major job here. Only taking the picture by the drone is not important. Important is the analysis part and taking the result to the field. So that analysis also chemometrics and all the image analysis required excessive training to our manpowers. So if someone is giving them, then we can send them to
Yes,
them from HCR side.
Sir, can I?
Yeah, Dr. Yeah, you can answer, Manzul, but I would add, but before that I will tell, I think the software and all Manzul has already demonstrated, it's all open source. The problem what we are having in India is, when you buy the drones, the people who are using not educated about even electronics, basic. Manzul also mentioned. So the whole, I will complete. We are doing. That's the reason this whole webinar started. So we will continue this. We make a proposal already. We have given the syllabus already. What electronic knowledge is required. That's what you're doing. Now, Dr. Manzul, please.
Thank you very much for your question. Actually, we started capacity building in drones in India, Indian students. So we are in Rahuri. They have less than 20 students here. So they were with us 1 month on drones as well as Google Earth. Second batch from Junagadh Agricultural University, they came also. So I think these are all World Bank, that national NH, the higher education project of ICAR. Under that, they have
the CAST.
The CAST, yes.
That is a very small and general type of training. I want the training for development of fabrication facilities in India. That we have
first of all, we have to, you have to have a team. Thank you. This cannot be discussed in this forum. Dr. Vajan Singh, any idea? Because this cannot be discussed in this forum. Because this has to be done from ICR and the people who are required. They have to discuss, because it's an open forum. Everybody listening is on Facebook. It's also on. So, but we will do. I think we found the need for it to do. Now, any other, Dr. Gajan Singh, you want to conclude with some of your remarks, please?
Well, I think I like the today's format, excellent format in a way, that very practical approach on the problem and the solutions shown, like demonstrating rice yield monitoring for UP, which is such a complex state, small farmers and all that in a huge area. And if that technology has been successfully used for yield estimation, I think it can be applied for the whole country with the same approach for different crops. And that will give us a really edge as an agriculture engineers if we really get into these technologies. Fabrication, I already mentioned in the previous session that I think CIAE and IERI or any other institute should take a lead in coming out with the solutions custom made, what is needed for different experiment, different research farms. I think Mr. Ramachandran is really an ideal example of a researcher. I'm fascinated that he is doing what we expect, Water Technology Center at IRI with a huge investment. And similarly, CIA also has a small setup, but they, with the irrigation drainage engineering group, they can expand quite a bit. What I did my work in 1986 at Rutgers University on drip, and basic thing was when to apply which nutrient in what quantity. Nobody in horticulture was able to tell me when to apply, how much is needed, because Ramachandran pointed out very good message. Plant, like human being, need food every day. It needs food, nutrition, and water every day. So you should think of applying it on every day as it is needed. So if we can use that approach and modify our research programs at ICR institutes, I think it will go a long way. And
Sir,
excellent, both
thank
of
you,
them.
sir.
Please,
Thank
please
you,
don't
Ramachandran.
interrupt. Please don't
Thank you.
interrupt. Please don't interrupt. Please don't interrupt. Yeah, go ahead, please, Professor Singh.
No,
Yes,
I'm done. I think I will
Okay.
again congratulate all of
Now,
you.
actually, when I called Manzul yesterday as well as today morning, actually, Ramachandran, he doesn't have a laptop. He doesn't have any pictures. He's broke down because of lockdown. He cannot get out. So we managed somehow this much. Because he is really keen interested to come out, and he is an example for us what this new engineers what we have to do in electronics. You recall Ramachandran he's not studied electronics, okay, but he tried with his friend. So what I'm telling is, if you youngsters can learn a little bit of electronics, how much you will come up. And with these few words, I think the time is up. Unfortunately, we cannot give any questions now. We have sent a questionnaire form to you. You can Google form is there. You can click and give your response in that. So then we can respond to all of you with the email of the whatever requirements you have. Okay. With that, I think Indramani, I think we'll close the session today. What do you think? You want to say something, Dr. Indramani?
Thank you. Just 1 minute. There are questions actually people are asking. Just we wanted to for the drama hack. And Sudarshan Biswal, he wanted to more clarification about NDBI and NDRE map. And then another question, I think their question was answered. So friends, we will take these, these questions, and you can write more, and we will send the email ID. Today's program was really interesting, as Professor Singh said. We have been saying that we should be covering from grassroots to global. So it was a real example of grassroots to global. Ramachandran Sahab shared the experience and how.
I think his voice is gone. I think we will consider it now. We'll thank. Hello, you can hear me.
And tomorrow we will have two very important speakers. Manoj Karki, he is associate professor at Department of Biological System Engineering, University of Washington State University, and Narendra Shah from IIT Mumbai, who is present in AIT. So please join us tomorrow, and we will try to have our technical session tomorrow. I'm sorry that we could not do the technical session, because these two talks were very, very important, and we and INSI decided that no, let it be presented fully, and so that proper message should go to the participants. Thank you very much for joining, and we will meet again tomorrow, same time. Thank you.
Thank you. Bye.
It's over now.